So in this video, we're going to introduce the concept of limiting and excess reagents. Obviously, in a chemical reaction, one of the products is probably going to be used up first, unless you're able to exactly calculate the correct stoichiometric ratios, which is one of the things that you would be doing in the lab. In this example I have here to get the concept understood is a recipe for raisin bread. Here's the recipe with all the ingredients laid out, and then inside my cupboard is the following. So I have all of this stuff, water's unlimited, and I know I have all these measurements. The question is, how much bread can I possibly make with all of this stuff? So one of these things is going to run out first, and that's the limiter to my baking. So if I have 18 packages of dry yeast, and I have 2 loaves being made for each time, that's going to mean that I can make 36 loaves of bread. Water's not going to calculate into this because I'm going to say I got basically an unlimited supply. I need 3 tablespoons of sugar. I have 210. So based on that, I can make 140 loaves because I can run the recipe, what is that, 70 times? Making 2 loaves each, 140. I can run the recipe 45 times here. I'd make 90 loaves of bread. 7 cups of flour, 56 divided by 7. I can make up 8 runs of the recipe. I can make up 16 loaves. And then 2 cups of raisins. I can run the recipe 12 times, and I can get 24 loaves of bread. So what this tells you is that my cups of flour is going to run out first. And so flour is what we call the limiter to this. So that's the idea of a limiting reaction, is you figure out what thing you have the least amount of. Same thing happens in chemical equations, except of course the recipe is the chemical equation. And you just have to go and calculate each of the possible products based on what you have. So the limiting reactant is the first thing that's used up in a reaction, and it determines the overall amount of product that you're going to get, because once you run out of the limiter, you're done. Reaction is over. So you figure out what your limiting reactant is, and then you can figure out what your yield is. The excess reactant is added to ensure that the other reactant is completely used up, and that's because this is usually the cheaper of the 2 reagents, or it's easier to recycle or clean up or whatever. So that's the definition. Let's take a look at an example. When we take a look at our example, we first of all have to start with a balanced chemical equation. For each reactant, we need to calculate the amount of product being formed. I'm going to calculate grams just to get practice in calculating grams, but you actually don't have to do that. You can just stop after 2 stops with moles, because moles and grams are basically the same thing. So once we know which one has the least amount of moles, that's still our limiter. So the smaller answer determines our limiting reactant, and that's going to determine then the amount of product that's made. So here's our example problem. I got 90 grams of zinc reacting with 81 grams of HCl, hydrogen chloride. Identify the limiting and excess reactants. How many grams of zinc chloride are made? First thing we need is a balanced chemical equation. Zinc plus 2HCl yields zinc chloride and H2. We're going to make a calculation based on, we're going to start this, we're going to calculate how much zinc chloride we're making with 79 grams of zinc. Now, I'm going to go gram to gram, but you don't have to. You could stop at moles to determine which one is the limiter. But I'm going to go ahead and calculate it all the way out to grams, because in the end, we have to know how many grams. So for zinc, I start with 79 grams, grams to the bottom, moles on top. Whenever we have a mole to gram ratio, it's always 1 mole to whatever our atomic weight is. In this case, because it's an atom, it's just zinc, it's an element. So I put that in. Now I got moles of zinc on top, so moles of zinc go on the bottom. And I need moles of zinc chloride, because I'm comparing zinc to the zinc chloride. So in this relationship, it looks like it's a 1-to-1 ratio, so that's fun. That's easy to do. Moles of zinc are going to cancel out. We're left with moles of zinc chloride on top. So moles of zinc chloride go on the bottom, and I need to convert that into grams. And when you have a gram to mole, this is where you do 1 mole to the mass. So Zn plus 2 Cls, I get 136.28. Now again, I don't really have to do this last step to determine the limiter. I could stop here at step 2 to determine how many moles of zinc chloride are made, and compare that then when I run the HCl calculation. So when all the smoke clears here, if you do your math, I got 164.5 grams. If you got your calculator, you should calculate that to make sure that that's the same. So now you just got to do this for the HCl. So we do the same thing. We got 81 grams of HCl, grams to the bottom, moles on top. The molar mass of hydrogen chloride is 36.46. Moles of HCl on the bottom, on the top, so it goes to the bottom here. So moles of HCl on the bottom. Again, I'm going to zinc chloride, but this time it's a 2-to-1 ratio. So I put a 2 with HCl, I put a 1 with zinc chloride. So I'm making half as much zinc chloride as I need HCl. Moles of zinc chloride to the bottom, grams of zinc chloride on top. We already calculated the molar mass in the previous problem. And again, you didn't have to do this step to determine your limiter, but if you want to do the grams, you've got to do the last step. So you could save yourself one step by not having to do this last term on one of these after you calculate your moles. So when I calculate this, I get 151.4 grams of zinc chloride. So what that tells me is this is my limiting reactant. So HCl limits my reaction. Zinc is in excess, and I'm going to end up with 151.4 grams of zinc chloride. And again, that's because our calculation for that was 164 versus our calculation for the HCl was 151. 151 is less than 164, so this is our limiting reactant. And again, you didn't have to do the last part to determine the limiter. Moles is fine just for that part. All right, so that's your gist. Your assignment in teams, you got 3 of these problems to work out. I will post the video tomorrow on their solutions. Thank you.